Hello guys, welcome back to my YouTube channel. Today we are going to study hierarchical RAG. For those who don't know, first step that we build this program, we build a naive RAG. So naive, what it does is that we ingest this data inside the vector store, and then based on the question that the user asks, we retrieve the top k clusters. That's the number of the top k relevant chunks, and then using those chunks plus the user question, we give it to LLM, and then it gives us an answer. So one advantage that this thing, that is the naive version had, is that it's pretty fast to build. Another thing that you have to understand is that it acts as a baseline tool for the rest of the future upcoming RAGs that we might be building. So the drawback of this is that you can't reformulate the question. So if a user asks a question that is like the language, they might not be so fluent in a certain language, so they ask a certain question in a small or minute way, and then the question you can't reformulate this question and give it to LLM to give us a suitable answer. So that becomes a blocker. So another thing is that the chunks that we might have retrieved might not be relevant. That means that it might be noisy or redundant. So that is the downside of it, of the naive RAG. Another downside of it is that we can't rank or validate the retrieved content. So that is not what we want over here. One problem that hierarchical RAG that solves is that what it does, you have to understand, is that it can help us in reducing the noise or redundant document that we might have. Why do I say so? It's because it has a parent child. It has a sort of a parent child way of retrieving the document. So the parent in this situation is that it retrieves the summary version of the document that you might have stored in the vector store. The child version of it is that it retrieves a very detailed version of that parent that is the topic that you retrieve in the first step. So the first step, first of all, is that you retrieve the summary. The second step is that you retrieve a detailed version based on the question that the user might have asked. So based on these two, you can now give it to the system prompt and then generate a relevant answer. So as you can see over here, I'm going back to the diagram that we have here. That is the hierarchical version. The hierarchical version, as I explained, is that the summary part, it has a table of content. What it does is that you retrieve the rough value of it. That is in that vector store. The second part, you retrieve a detailed value, detailed chunk based on the question that the user might have asked. So it is very detailed. It is very detailed. So this one helps us in getting the right question, the right answer to the question that the user might have asked. So how or where can we use this type of RAG? It is relevant when you have a big document. Like, for example, you might be using a certain medical document over there. So the document might be huge and you can't really go ahead and just retrieve the top K clusters over there. So you have to first of all check the table of content, and then based on the table of content, you retrieve that table of content data and then give it to the system prompt, and then the system prompt itself will generate an answer. So that is the advantage of it. The downside of it is that it is pretty slow, because now you have to search in two areas, or maybe if your program is very systematic, you have to search the summary first, and then you have to go ahead and based on the summary, you have to go ahead and search in level 2, the retrieval, the second chunk, that is the detailed version of it. So that is how you can use it. That is the limitation of it. But the advantage of it is that it reduces the noise that we had in the naive version. So just to show you this program, I'm going to run it. So the question that we have over here is, what are the surgical steps for mobilizing the bladder and preventing uterine injury during hysterectomy? Yeah, you have to remember that we are doing this hysterectomy, the removal of uterus. So the first step is split the document, the text into two sections: the summary and the detailed version. So once you have to do the summary of the table of content, this is the detailed version. So that means that we are building this part based on the document that we have. The document that we have here is a hysterectomy paper and a URL, that one that we had in the past. first part. I'm going to show you the program in case this is your first time looking into hierarchical RAG. So just be patient. So once we retrieve the data over here, we generate an answer based on the summary and the detailed version that the detailed context that was retrieved. So what are the surgical steps for mobilizing the blood and preventing uterine injuries during hysterectomy? So the surgical steps are given over here: mobilizing of the bladder, hemostasis, that is using a bipolar coagulator to coagulate any bleeding during the mobilization process. And then these are the steps. You can just read through this response over here. So I'll go back to the code base so that I can show you what is happening over here. So what do we have over here? The path to the document that we have, hysterectomy PDF, the website that we shall be scraping, the model that we shall be using, ChatGPT 4.0. So this vector store API is just to help us in knowing the SDK that you're using. If you're using version 1, you'll use the beta version. If you're using version 2, you'll be using the client vector store. So this is just a caretaker of the right program to use over here. So the first step is scraping the website. As you know, once we scrape the website, we have to divide it into two sections: the detailed part and the summary part. The detailed part becomes the parent, that is the parent itself. So it is just a summary of the document. So what it does is that it goes ahead, breaks it into summary and the detailed version. So what do you do in the summary part? The summary generates a short summary for each section, and then we store it inside the vector store. So we have a prompt here to just summarize the content, and then building the hierarchical store. Now this is the part that I want you to be very careful. I told you there are two parts: the summary section and the detailed section over here. This is just the rough part, the fine part of it. I want you to look at here. We are building a vector store. The first vector store that we are building is the hierarchical summary. And then the second vector store that we are building over here is the detailed vector store. Of course, we are using OpenAI. It has a deadline. You can use the other type of vector store, Pinecone, whatever you want. And then once we have that one, we retrieve the chunks. So once we retrieve the chunks, so we retrieve two parts: the summary part, and then the other part retrieves the detailed part based on the question that the user asked. So once we retrieve, this is the retriever, the second retriever, the detailed retriever. So it just retrieves the detailed part of it. That's the fine part, and then we build a context based on both of them. Okay, and then this one generates a response to based on the context. So yeah, this is a pipeline of it. Split into sections, the summary section, then build out two vector stores. The two vector stores that we have is the parent and the child. The parent is the summary, the child is the detailed part, and then retrieve the response based on the context, and then answer the question. So that is the advantage, the way we build the hierarchical RAG. You can use it in long documents. So limitation is that it requires two vector stores. You can see over there. So the quality depends heavily on how good your summary are, and then the ingestion process is quite slow. So in the next step, I'm going to show you the next RAG. That will be the hybrid RAG. So thank you.